I think we're all aware that radiation is damaging to living organisms. And when we talk about acute radiation damage, this is where there's a large exposure in a short amount of time. Acute as opposed to chronic exposure or damage. Main sources of acute radiation damage are going to be nuclear bombs and exposed nuclear reactor cores. So, nuclear power plant, accident, or a bomb going off. These are not things that we have to worry about on a daily basis, right? What happens in acute radiation damage? A large number of cells die. And these are largely the ones that are reproducing quickly. And so these are especially in the immune system and the intestinal lining. And so the result of this is a weakened immune system and an inability to absorb nutrients because your intestinal lining is not functioning well, and so you can't absorb nutrients. So a mild case of acute radiation exposure you may be able to recover from, but death results from more extreme cases. And it's not from the damage itself, it's the result of the damage, which is generally infection. So your body's immune system is greatly weakened, so you can't fight off infection, and then the infection is what kills you. And then the ability to absorb nutrients also weakens your body. I think one of the things that most people are worried about is increased cancer risk from exposure to radiation. So lower doses over long periods of time can increase cancer risk. And this can happen because the radiation can damage your DNA. So the DNA, these are molecules that carry the instructions for cell growth and replication. And if the DNA is damaged, then your body's using the wrong instructions. Radiation damage usually will kill the affected cells, but sometimes it can cause them to grow abnormally and become cancerous. Cancer risk would increase with increasing radiation exposure. The more radiation, the more cancer risk. But there's no exact threshold for when you have an increased risk of cancer from radiation exposure. Radiation exposure can also cause genetic defects in future generations. If the DNA in your eggs or sperm are damaged, then the offspring could have genetic abnormalities. Genetic defects like this have been observed in laboratory animals, but have not been verified in humans, even in studies of Hiroshima survivors, which, it's hard to find humans that have been exposed to large amounts of radiation, right? But they studied Hiroshima survivors, and they did not find any genetic defects as a result of radiation. But we know it's possible because it has been generated in laboratory animals. So earlier we talked about measuring radiation. Now we're going to talk about measuring radiation exposure. And this is actually more complicated than you would think. So radiation exposure can be measured as the number of decay events that you're exposed to. There's different ways of measuring exposure. So 1 Curie, which is abbreviated CI, is 3.7 times 10 to the 10th decay events per second. So you could measure how much radiation someone was exposed to. This doesn't do much good, though, because the Curie is not an effective measure of how much biological tissue damage will actually occur, because different types of radiation cause different effects, right? Alpha, beta, gamma, different levels of ionization power and penetration power. And so just looking at the decay events per second doesn't really give us a good measure of how dangerous this would be. So a better way to do it is to measure the radiation dose, or the amount of energy that's actually absorbed by body tissue. And the unit for this, which I'm just telling you about, we're not actually going to use it, is a gray. And that's 1 joule per kilogram of body tissue. Another unit is the rad, which you may have heard of. 1 rad is 0.01 joules per kilogram body tissue. And rad is an acronym standing for radiation absorbed dose. Just measuring the energy absorbed still doesn't account for the amount of damage, because gamma rays have low ionization density, alpha rays have high ionization density. Ionization density, because of the differences in penetrating power. So another way to measure it is biological effectiveness factor, or RBE, relative biological effectiveness. They use a correction factor multiplied by the dose in rads to obtain a dose in REMS. And REM stands for Röntgen equivalent man. So the Röntgen equivalent in humans. So the dose in rads times RBH is equal to the dose in REMS. So this factor, RBE, is much higher for alpha radiation because it causes a lot more ionization, a lot more damage than for gamma radiation. Gamma radiation penetrates stuff a lot better, but it doesn't do as much damage to the actual tissue. This is just an interesting table. Radiation dose by source for persons living in the United States. Natural radiation. So if you go on a 5-hour jet airplane ride, you're going to be exposed to more radiation than if you stay on the ground, just because you're closer to the sun and there's less atmosphere to filter this out. So at 39,000 feet, 2.55 millirems per 5-hour trip. Cosmic radiation from outer space, you're going to get 27 millirems over the course of a year. Terrestrial, this is radiation from the Earth, 28 millirems per year. Natural radionuclides in your body, 35 millirems per year. You can't get away from those, right? You could try to shield yourself from cosmic radiation or from terrestrial radiation, but you can't shield yourself from yourself. Radon gas is another significant source of natural radiation. And that, I guess an average is 200 millirems per year. And that's not in your whole body, that's going to be in the lungs because radon is a gas. So around here, radon gas is not a big problem, but in the Midwest, it is a significant problem because people have basements. And there's radon gas being naturally produced, and it comes out of the ground, and down in your basement, there's likely to be a higher level of radon gas. You go down there, you breathe the radon gas, it gets into your lungs, right? And so that's not good. And so there's a whole industry in radon gas abatement of how to seal up your basement to keep the radon gas out. Medical procedures, not a natural source, but these are different types of radiation that you would get from a medical procedure. Chest x-rays, dental x-rays, mammograms. Those are pretty common. And then there are some of these more specialized tests, like a CT scan, computed tomography. And so, again, these are in the millirem region. Consumer products can also expose us to radiation. Building materials, luminous watches, which they don't use radium anymore, so that's good. But they do use tritium and PM-147 for that glowing. So yeah, maybe a digital watch is better if you need to see it in the night. And then tobacco products. Look at this, 16,000 millirems per year for someone who smokes 30 cigarettes a day. That's huge, right? No, they've told us about all these other dangers of tobacco use, right? But you don't hear about this one. Just smoking, it's bad. Just don't do it. Don't start. Any questions? Yeah.
Where does the radiation from tobacco products come from?
That's a good question. Where does radiation from tobacco products come from? It's got to be something that is present in the tobacco itself. Yeah. So that's an excellent question. I have no idea. Excellent question. Any other questions? So it takes a lot more than just your average natural radiation dose. Man, there's so many typos in this slide. Female deer have nothing to do with this. Radiation dose is a lot more than natural radiation or from a single medical diagnostic procedure, even several diagnostic procedures. So the doses in the previous slide, in the previous table, were in millirems, and these are in rems. So this is 1,000 times more. And so these are probable outcomes from various doses. Decrease in white blood cell count, possible increase in cancer risk. Radiation sickness includes vomiting, diarrhea, skin lesions, increase in cancer risk. 500 REMs will often produce death within about 2 months, 1,000 death within 2 weeks, and 2,000 REMs death within hours. And so these are the sorts of doses that the people who were killed by the Chernobyl nuclear accident died from.